Dear friends, good morning to everyone. We have dealt with the synthesis of many drug molecules containing heterocyclic molecules as the basic ring system. Today, we can deal with another heterocyclic system containing drug triamterene. Triamterene is a potassium sparing diuretic. This diuretic is used in combination with thiazide diuretics for the treatment of hypertension or edema or hypertension with edema. It's basically a pteridine ring system. The pteridine ring system is a pyrimidine ring system. Pyrimidine is a benzene ring system with two nitrogens at 1 and 3 position, and a pyrazine ring system with two nitrogens, a benzene ring system with two nitrogen at 1 and 4 position. Pyrazino-pyrimidines, they are called pteridines. Chemically, this is, I can number this from here: 1, 2, 3, 4, 5, 6 and 7. Sixth position, there is phenyl group, 6 phenyl pteridine 2,4,7 triamine. How can we synthesize this? Applying the retrosynthetic approach, I can cut this molecule over here. This is 2,4,6 triaminopyrimidine. I have to construct the pyrimidine ring system first, and onto this pyrimidine ring system, I should build up the structure of pyrazine ring system. I can cut over here, and pyrimidine ring system, if I take NH2C double bond N, this can act as one synthon, this part. This part can act as one synthon system. NH2C double bond N. Here, the guanidine can act as a reagent for this synthon, and here 1, 2, 3 carbon donor I have to take, which is attached to again nitrogen. That's why I can take guanidine as one of the starting material, and this 3 carbon donor I can take melanonitrile. Then on that, after constructing, I can add this PHCH and CHNH2. Let us look into it. I take guanidine. It is easily available chemical. Melanonitrile CH2Cn twice. As the carbon in the cyano is electron deficient due to the presence of the adjacent electron withdrawing group, that is nitrogen. The nitrogen in the guanidine ring system has lone pair of electrons, as nitrogen is in sp3 hybrid form. Is electron rich and is electron deficient. Unlike poles attract each other. The pi electrons over here moves onto the nitrogen. It becomes electron rich, and this electron rich nitrogen attacks on the nitrile carbon. Once the bond is formed between this carbon and the nitrogen and the nitrile carbon, this has to maintain its tetravalency. Already it's tetravalent and one more bond has formed. That's why, to maintain its stability, one of the pi electrons shift on to the nitrogen, and nitrogen combines with hydrogen. The lone pair of electrons on the nitrogen attacks on the another nitrile of the melanonitrile group, and similar pi electron shift occurs, and I will get a cyclized ring system. Now, this undergo aromatization for its stability. The nitrogen hydrogen bond breaks and that electrons moves towards the adjacent carbon, and as these electrons over here has moved, this is positive center, and once the bond is formed over here, the carbon become pentavalent, and to maintain its stability one of the pi electrons is shifted onto the nitrogen becomes electron rich minus, and this excess electrons it combines with this H plus. Similarly, the carbon hydrogen bond breaks and these electrons or excess are shared with the adjacent carbon, and the carbon become pentavalent, and to maintain its tetravalency for its stability the pi electrons moves onto nitrogen has to maintain its trivalency, but it is electron rich now, and that combines with this hydrogen H plus, and to satisfy the positive center over here the nitrogen hydrogen bond breaks and these electrons moves onto this adjacent carbon, and overall the aromatization has occurred, and this occurs for stabilization of the ring system. As we know that aromatic compounds are more stable. Now here there is nitrogen. I have to add nitrogen over here. To add over nitrogen over here, I'll take sodium nitrite and HCl and treat it at 0 to 5 degrees centigrade. Sodium nitrite reacts with HCl, Na plus, NO2 minus, H plus, Cl minus. Cl minus combines with Na plus, giving rise to NaCl. H combines with NO2 minus to give HNO2, and it gives rise to OHN double bond O. That is nitrous acid. Nitrous acid is a reagent which should be prepared in situ as it's highly unstable. This in situ prepared nitrous acid reacts with this triamine pyrimidine. The nitrogen in the nitrous acid is electron deficient due to the presence of electron withdrawing group adjacent to it, and this electron deficient center, and it can act as a weak electrophile, and in the presence of electrophile the pi electrons moves because of this electromeric effect, giving rise to carbanion. These excess electrons forms bond with nitrogen, and the OH gets kicked off. I'll get corresponding nitroso derivative. I got nitroso compound. 5-nitroso 2,4,6 triamine pyrimidine. As the electrons are moved and that is shared with nitroso group, and this carbon has become electron deficient as it has lost its electron. To satisfy this positivity, the carbon hydrogen bond breaks and this loses as H plus, and this regains its aromaticity with nitroso group attached at the fifth position. Reduce this by using catalytic agent like hydrogen and palladium. I'll get corresponding nitroso group reduced to amino group. 2, 4, 5, 6 tetra amino pyrimidine. Now there is lone pair of electrons on the nitrogen. I take benzaldehyde, I have to add PHCHO, attacks on the carbonyl carbon of the benzaldehyde. Pi electrons moves on to the oxygen and it becomes NHCOHPH. On strong heating, the nitrogen hydrogen bond breaks and that excess electrons forms bond with the adjacent carbon, and OH gets kicked off. Dehydration takes place. H plus here and OH minus combine together to lose as water molecule and get an imine derivative. Aldehyde react with amine to get an imine. The imine which is formed, to it I treat with hydrogen cyanide. I want to add cyano group over here. This is the positive center due to the electronegativity of this adjacent nitrogen. And it has to maintain its tetravalency. Pi electrons moves onto the nitrogen. And I'll get NHCPHCN. As these electrons are moved away and this becomes a positive center over there. Then the lone pair of electrons on the nitrogen attacks on the nitrile carbon and it has to maintain its tetravalency. Pi electrons moves onto the nitrogen. The cyclization of the ring occurs. And here these electrons are taken away. That's why this is the positive center. The nitrogen hydrogen bond breaks and that electrons are utilized to satisfy the positive center. Then the nitrogen hydrogen bond breaks over here and these electrons are utilized to form the bond with the adjacent carbon. This is electron deficient due to the presence of the electron withdrawing nitrogens over both the position. And to maintain its tetravalency, pi electrons moves onto the nitrogen. N nitrogen becomes electron rich and this excess electrons combines with this H plus and it forms NH2. Have got 6-phenyl 2,4,7 triaminoteridine, that is triamterene. It is a potassium sparing diuretic which has been used along with thiazide diuretics for the treatment of hypertension. This is the one of the drug of choices used for the treatment of hypertension, especially when we require potassium sparing diuretics. Next class, we can deal with another drug containing an heterocyclic molecule and its synthesis. Till then, have a nice day. Thank you.